My dear friends, welcome to Rajashekar classes on applied data science with Python. This is lecture number 475. In this lecture, we will try to understand limitations of k-means. Now, let's look at the limitations of k-means. There are few limitations. Again, using the same slideshow which we discussed in my previous lecture notes that we referred to in my previous video. So some of the key limitations of k-means we will show diagrammatically. Actually, there are four basic limitations. When you have clusters of different sizes, k-means may not work as well as you expect. When you have clusters which are of different densities, and when you have non-globular shapes, globular shapes, or I can say non-convex shapes, k-means may not work. I will explain what each of these cases. K-means typically tends to have problem when the data contains outliers. For each of these cases, let's go through some examples one by one. Imagine if my original data is like this is my original data. Let me assume this is my original data points. Yes, imagine if my original data is like this. In this original data, if you notice, I basically have three clusters. Just observe, I basically have three clusters. I have a small cluster here. I have a small cluster here. I have a small cluster here. Here I have large cluster, isn't it? All of them are marked with this cluster. Yes, I have clusters with different sizes, isn't it? If you give this data without coloring, without coloring, a 5-year kid, a human will label it, isn't it? A kid can label it and saying that this is one cluster, this is other cluster, this is other cluster, isn't it? Yes, even without coloring, isn't it? Even without coloring, a 5-year kid can label these clusters, isn't it? But what happens when you give this raw data, but what happens is when you give this raw data without clustering to k-means algorithm, what happens is here is a clusters of different sizes. Yes, this cluster, clusters of different sizes. This cluster, middle one, this is larger one. Middle cluster is, let me say, is it not larger one? Middle one. Then this one is larger compared to these two clusters, isn't it? These clusters of, I can say, these clusters of different sizes. What happens when we apply k-means? When we apply k-means with k equal to 3. When you apply that, what you end up getting is you get clusters like this. Even with the different initialization. You will get clusters like this. Even with the different initializations. Even with different initializations, you will not get a cluster like this. Isn't it? You will not get cluster like this easily. Reason for this is k-means tends to prefer to create clusters which are of roughly same size. Roughly same size. Roughly same size, isn't it? I will repeat. K-means tends to prefer to create clusters which are roughly of same size, just like this one, just like this. Yes. It tries to create clusters which are roughly of same size. It always give results somewhat. It always give results somewhat like this. Somewhat like this, isn't it? Not like this, not like this, like this only, isn't it? Not like this. It gives results like this, isn't it? Now how do you get around this problem? We will discuss it. Remember, these clusters are of different sizes which are also close together. Just see, these clusters are very close, isn't it? The gap is very less. These clusters are of different sizes which are also close together. This is the problem that often occurs. If these clusters are far away, this problem would not have occurred. But these are different size clusters and close together, and hence we tend to see problem like this. The second type of problem or limitation with k-means is, the second type of problem or limitation with k-means is when you have data with different densities, isn't it? For example, look at this data. Yes, this one, even without this coloring, this is all one cluster, isn't it? This is one cluster, isn't it? This is one cluster. This is other cluster. This is other cluster. But if you notice, in this region points are dense. Just see, in this region points are dense. In this region also even points are dense. Even here the number of points per unit area are large. Here dense. You have dense clusters. So this is dense and this is also dense, isn't it? What about third cluster? This is sparse. So there is a density differences amongst your clusters. So when you apply k-means, when you apply k-means for k equal to 3, you will end up clusters like this. You will end up clusters like this, isn't it? You will get this as one cluster, this as one cluster, this is other cluster, this is other cluster, isn't it? Of course, there is a size differences also, but there is also density differences. So when your clusters are of different densities, k-means tends to stretch them out. How can I say this one? Just say this: when your clusters are of different size, clusters, when your clusters are of different, I can say different densities, k-means tends to stretch them out, stretch them out, isn't it? K-means tends to cluster of same size, also cluster of similar density, same size and similar density, isn't it? Try to, it always try, I say k-means tends to cluster of same size, also cluster of similar density. So whenever initialization you try to do, it always try to give a resulting cluster which is like this, isn't it? K-means tends to fail, especially when you have clusters of different densities. Similarly, there is a third problem. Which is called non-globular shapes. Non-globular shapes, isn't it? Also called non-convex shapes. Non-convex shapes. Non-convex or non-globular shapes. We will discuss this in my next lecture. Just time being, go through this lecture. If you have any difficulty, please keep a comment. Thank you very much.